Comfloor is a composite steel floor decking, ideally suited to modern high-rise structures. Available in both shallow and deep decks, the Comfloor range represents some of the most economical floor solutions and is arguably the most efficient choice of profile currently available anywhere in the world.
A composite floor is one in which the steel deck mechanically bonds with the concrete topping, so that the steel and the concrete work together to form the floor structure. The technology reached the UK at a time when the concrete had a dominant three-quarter of the market for multi-story building. The introduction of steel profile using composite slab technology changed the market forever. And today, 70% of multi-story buildings are steel framed. The principal benefits of building with composite steel flooring system are increased speed of construction. The deck instantly acts as working platform. Construction stage bracing, providing diaphragm action to the floor. Reduction in the weight of the floor, overall building height reductions, inherent fire safety property, and the simplicity of attaching building services. Circular embossment in particular reduces the amount of distortion created during the rolling of the deck. This later leads to reducing residual stresses within the profile, which help the flatness of the deck. The embossment along with the round edges increases shear bond action between the deck and the concrete slab and has led to increase in the M&K value found from the test that was carried out here at Imperial College. As with any construction product, this decking are tested to European standards. Eurocode 3 for cold form steel and Eurocode 4 for composite slab and beams.
The Comfloor 80 and the Comfloor 60 profiles were designed to span further in the unpropped condition over any other profiles in the world. Having a profile that spans further is only half the story though, because in floor areas where the spans are not so important, it means the gauge thickness can be reduced. Smaller gauge thicknesses means that the overall floor cost can be dramatically reduced. Deck design is not an exact science, however,
one of the key areas for the design of these profiles is to try and ensure that the cross-section of the profile is fully effective.
the introduction of the large corner radii is to reduce the individual element lengths of the compression zone of the profile. The CF60 and the CF80 are circular embossments. The purpose of these circular embossments is to ensure that the concrete works with the decking.
They put less stress into the profile, which actually means that there's no twisting of the profile. So when it's laid in situ, the decking actually sits firmly onto the top flange of the beam.
When you look at the cross-section of these new profiles, you'll notice that the bottom stiffeners in the trough have actually been pushed apart, as opposed to a traditional central stiffener. By doing this, the shear stud connector can be placed centrally within the trough.
And this means that the stud will achieve its full capacity.
Comfloor decking will span further than any other flooring deck profile. In the double span condition, Comfloor can span in the region of 4.5 to 5 metres without the need to prop. In a typical grid structure, traditional composite decks require a greater frequency of beams. The use of Comfloor can reduce the number of components by as much as 25%. Let's consider a typical crest configuration with a central stiffener. As the horizontal elements will at some point be in compression, it is important to keep the individual B/T ratios for these elements to a minimum. The location of the shear stud connector within the deck profile is of paramount importance. The latest Comfloor profiles only allow the studs to be centrally placed, which is the optimum position for developing the stud capacity. Extensive testing and fire engineering work have resulted in fire ratings of up to 4 hours when using a light mesh within the composite slab and no protection to the deck.
We are proud that we have a very high quality controlled manufacturing process. At the beginning of each order, then at regular intervals, quality checks are carried out on the Comfloor. Only once these checks are satisfied will production continue. Comfloor has gained great favour since the launch of Comfloor 80 in 2004, with hundreds of thousands of square metres supplied all over the globe and demand only growing the world realises the great benefits of the Comfloor composite floor system.
Essentially, it starts when we got our steel frame erected, and obviously we hang safety netting beneath the floor where we want to be working. The steel composite panels actually come in bundles on the back of a flatbed and lifted onto site by crane. And typically then we take from these bundles of, say, 15 sheets, they're actually placed in position and then fixed to the beams. Once the deck is then laid in position, it becomes a working platform, but also is a crash deck, and so allowing work to carry on unimpeded on the levels below. The shear studs are then taken and placed in position through deck welded onto the composite beams. The steel mesh is then laid, concrete poured, and then it's finished.
Comfloor is a high-quality composite decking product, manufactured with tight controls on testing and packaging. It has been proven to provide significant savings in both construction time and overall structural costs in buildings all around the world.
Comfloor 210 was introduced to the New Zealand market in 2002 and has been used in the United Kingdom for over 20 years. Comfloor 210 is best used in a single span configuration where the 210mm deep profile is fully or partially incorporated within the height of the supporting beam, resulting in a reduced story-to-story height when compared to using metal deck laid directly on top of the beam. Comfloor 210 is very economical in terms of concrete volumes used. This is due to the deep beam-type troughs that provide the spanning strength, while the broad top of the profile minimises the amount of concrete used overall. Comfloor 210 suits construction that requires large spans, but also demands a thin overall floor system, that is the total floor system height inclusive of the beam. Comfloor 210 has the longest unpropped spanning ability, over 5-metre beam centres. When temporary propping is used, spans of over 8.5 metres are possible. Comfloor 80 was introduced to the New Zealand market in 2005 and has been used in the United Kingdom since 2004. Comfloor 80 is best used where long sheets continue over multiple beams to fully utilise the fantastic spanning capabilities and construction bracing properties of Comfloor 80. And as such, it suits high-rise construction and where a simple, large spanning and lightweight flooring system is required. Comfloor 80 is a great balance between economic concrete use and robust acoustic and fire performance, achieving 4 hours in fire testing without any modifications to the underside of the decking. Comfloor 80 can span unpropped to over 4.6 metre beam centres. When temporary propping is used, spans up to 7 metres are possible, meaning Comfloor 80 is a great all-round choice for your project. Comfloor 60 was introduced to the New Zealand market in 2008. Comfloor 60 is similar in use to Comfloor 80, but is better suited when the thinnest possible slab is required or where acoustic, fire and vibration criteria are critical factors in the design. Using less material width in its manufacture, Comfloor 60 also comes at a lower unit cost than the Comfloor 80. Comfloor 60 is great for commercial car parks and storage units, or anywhere a long-spanning, concrete-efficient slab is desired with good solid performance characteristics. Comfloor 60 can span unpropped to over 4-metre beam centres. When temporary propping is used, spans up to 7 metres are possible.